The SAID principle, or specific adaptations to impose demands, tells us the demand placed on our body dictates the type of adaptation that will occur. Many of us have a general understanding of the SAID principle, but it's often used to communicate how specific training leads to sport performance, which is a short-sighted view of its implications. In this post, I'm going to give you a different perspective. Let's discuss just how adaptable the body is to training. Hip and groin injuries are thought to be relatively common in professional ice hockey players. The biomechanical demands of skating and the extreme ranges of hip motion may be contributing to bony changes observed with imaging. Some evidence has shown over 85% of these athletes have bony changes to their hip, specifically an overgrowth of bone around the femoral head known as a cam-type morphology. This causes the femoral head to lose its spherical shape and can restrict the athlete's hip motion. Baseball pitchers undergo some of the most extreme biomechanical demands of any sport. During a pitch, as the ball is propelled forward, the arm will internally rotate at velocities of 7,000 to 9,000 degrees per second. If a pitcher's arm kept up that velocity, the arm would make over 20 full revolutions per second. As the arm follows through, the amount of distraction force generated is equal to nearly 1 times the athlete's body weight. That means a 200-pound pitcher has nearly 200 pounds of force pulling his arm away from his body, and the shoulder muscles have to counter these extreme forces. Retroversion of the humerus, which is a posteriorly rotated position of the humeral head, decreases with age, from an average of about 78 degrees in a human fetus to about 30 degrees in adults. In throwing athletes, the forces caused by repetitive throwing are thought to restrict the derotational process of the humerus, leading to a larger degree of humeral retroversion in the throwing arm. This process is seen in throwing athletes as early as the 4th grade. Humeral retroversion results in changes to the thrower's range of motion, where they gain some external rotation and lose some internal rotation. This introduces a very important concept: total arc of motion, which is the combined total motion occurring from external rotation and internal rotation. If the thrower's left arm has 90 degrees of external rotation and 70 degrees of internal rotation, then total arc of motion is 160 degrees. If their throwing arm has 120 degrees of external rotation and 40 degrees of internal rotation, their total arc of motion is still 160 degrees. This means the coach or clinician should not stretch out the arm to gain the same amount of internal rotation as the other arm, as this increases the total arc of motion and creates an unstable shoulder. The takeaway message is our bodies can undergo significant changes to meet the demands of our activities. This is one of the reasons why adolescent athletes should consider multiple sports rather than early specialization, and illustrates the importance of training variety in adults. I hope this was informative, and please share with anybody that you think could use the information.